This is 3-4, multiplication, division, and simplification of surds. In this lesson, you're going to learn how to properly multiply, divide, and simplify surds. Your objective is you're going to use the rules of surds and perfect squares to properly multiply, divide, and then simplify surds. Make sure you pause the video and write this in your notebook. Our fun fact for the day is, why is the ring of fire called the ring of fire? And the ring of fire refers to this area in darker red that goes around the Pacific Ocean. Rules of surd, a recap. We have the square root of a over b is equal to the square root of a times b. So what that means is if I have the square root of 3 times 16, I can separate that into the square root of 3 times the square root of 16. Why would we do that? Because then I can take the square root of 16 by itself. That's going to be the square root of 3 times 4, which comes out to be 4 square root of 3, final answer. We're going to do a lot of that today. Square root of a over the square root of b, we can put it all underneath the same surd, or we can split it up. So remember, this is going to go backwards and forwards, either way. So again, we could have the square root of 3 over the square root of 16, square root of 3 divided by 16, okay? Or if we were given, in this case, 3 over 16, this would work out easier because then we would break it apart, and then our final answer would be square root of 3 over 4. It just depends on what we need to do, whether we need to put them together underneath the same radical or if we're going to separate them. Rule number 3, when we have the same numbers in the same surd, the same root, then when they multiply together, we just have the number. For example, if I have the square root of 3 times the square root of 3, the final answer when I multiply these together is just 3. And again, this kind of goes back to the first problem, the rule 1. What this means is, because I can put them together, and 3 times 3 is 9, and if I take the square root of 9, I get 3. So that's how that works. Now let's add in some simplification. So we're going to simplify a couple of surds. First one we have, we're going to use the multiplication rule in perfect squares to simplify. Remember, you have to memorize those perfect squares. So we're going to simplify the square root of 50. Our first step in doing this, step number 1, is determine the greatest perfect square factor. So you're going to factor 50. That means you're going to break it down into two numbers that multiply to 50. Okay? And you want to have a perfect square as the factor. So if I think about 50, 50 can be 50 times 1. It can be 25 times 2. Bingo, there's that. 3 doesn't work, 4 doesn't work. It could be 10 times 5. Okay? But I want one that has a perfect square as a factor. That's 25. And I want the greatest one. So going back to our rules, we're going to take the square root of 50 and we're going to break it down into 25 times 2. Now this means I have the square root of 25 times the square root of 2. Those are my rules. I'm allowed to break it apart like that. Well, the square root of 25 is just 5. So I can't do anything with the square root of 2. It is a surd. Okay, this is a surd. It's irrational. So my final answer is 5 square root of 2. Go ahead and try this next one. So pause the video and try this next one. It's going to be a little bit longer, but I think you can do it. All right, so I'm going to go ahead and do it. Now I have 117. And again, I'm trying to find a perfect square. Now, I'm going to do this using the factor tree as another way of determining perfect squares. If you remember a factor tree, I start going through the factors. I can't divide 117 divided by 2. That doesn't work. So I'm going to do 3. 3 works. I get 39. Neither one of these are perfect square. So I divide by 3 again, and I get 13. Okay, I don't have a perfect square, but I do have 3 and 3. Well, that's going to make 9. So 9 times 13 is 117. This might help you quickly find the perfect square. So I have 9 times 13. So I'm going to break it apart, just like so. This becomes 3. I have 3 square root of 13. Final answer. When adding and subtracting, we have to simplify terms. And our goal when we do this simplification is we want to create like terms that we're able to combine. Meaning, remember, we want the same radicals or the same surds. Okay? What I mean by this, we have the square root of 8 plus the square root of 18. So I'm going to go ahead and simplify these. Well, square root of 8, the square root of 8 is 4 times 2. So I'm going to get 4 times square root of 2. I get 2 square root of 2. The square root of 18 is 9 times 2. So the perfect square is 9. So I'm going to get 3 square root of 2, right? Take out the square root of 9. So I can add to this 2 square root of 2. I can add 3 square root of 2. I now have like terms. So my final answer is 5 square root of 2. Go ahead and try. This one's going to have 3, so I want you to pause the video and I want you to give this one a try. See if you can figure out which the radical has to be the same. See if you can break it down. All right, so I'm going to go ahead and do it. I have 3 square root of 20, 3 square root of 80, and 2 square root of 45. So I'm going to break down 20, and instinctively I say, okay, that's going to be 4 times 5. Then I break down the 80. Let's go ahead, actually, let's finish this first term initially. So we have the square root of 4, like so. Square root of 4, though, is 2, so now I have 3 times 2, which is 6, so I have 6 square root of 5. Now I'm going to do the second term. I have 3. Now I'm looking at like I have the square root of 5. Well, I know 5 goes into 80. So 5 times 8, or 5 into 80 is going to be 16 times. Oh, great, perfect square. So 16 times 5. So I break this down. Negative 3 times the square root of 16 times the square root of 5. So this is going to be the negative 3 times 4, which is negative 12, square root of 5. Do you see how this is working out? Again, I have square root of 5. Minus, okay, now when I break this down, I'm going to have 9 times 5, right? So I have negative 2 times the square root of 9 times the square root of 5. Take this out, I'm going to get 3. Negative 6, right? Negative 2 times 3 is 6. All right, so now I have all like terms. So I have 6 square root of 5, negative 12 square root of 5, negative 6 square root of 5. 6 plus a negative 12 is negative 6. Negative 6 plus negative 6 is negative 12. Okay. Some of you may have also seen, well, I have the 6 square root of 5 and a negative 6 square root of 5. You may have seen this and you can realize, well, these cross out, just leaving me with negative 12 square root of 5. All right, these are a little bit harder for division. Okay. Divide what you can. That's an ambiguous statement, but see if you can figure out how I do this. All right, so I'm going to go ahead and simplify like we've been doing. So I have 3 square root of 18, and I'm going to break that down into 9 times 2 over 2 square root of 2. Well, I take the square root of 9, right? This is the same as 3 times the square root of 9 times the square root of 2 over 2 square root of 2. Well, the square root of 9 is 3, so then I have 3 times 3. 3 times 3 is 9 square root of 2 over 2 square root of 2. Now what I want you to see here is square root of 2 divided by the square root of 2 is 1, right? This is a 1. So my final answer is 9 halves, because 9 halves times 1 is 9 halves. Hopefully you understand how I cross those out. So here's your next one. This one's a little harder. I have basically a division problem inside, but I also have multiplication here because of this squared here. So I'm going to take this and multiply it by itself. So I have 2 square root of 6 over 3 times 2 square root of 6 over 3. Now this gives me a chance to explain a couple of things when multiplying radicals, right? So when you multiply radicals, you multiply what's on the outside, and then you multiply what's on the inside. So 2 times 2 is 4. Square root of 6, square root of 6. Remember, we can make this the square root of 6 times the square root of 6, which is square root of 36. So I'm going to have 4 square root of 36. Now when we multiply multiplying fractions, 3 times 3, we get 9. Now look at this, you see, okay, I have 4 square root of 36, but the square root of 36 is 6. So I have 4 times 6 over 9. So I have 24 over 9. Be very careful here. It is a fraction. You must always simplify your fractions. You can divide both of these by 3. So you get 8 over 3 as your final answer. You will lose a point if you leave this as your final answer. So make sure that when you do it, I'm looking for 8/3. You'll get most of the credit for giving me 24/9, but you'll miss a point for not giving me the 8/3. Using the distributive property. So we're going to do what we just did, okay? But now we're going to distribute as far as the multiplication goes. So I'm going to take 2 square root of 2, and I'm going to multiply it times 3 square root of 2. And then I'm going to take 2 square root of 2, and I'm going to multiply it times negative square root of 12. Remember, that's a negative sign goes with that. So we have 2 times 3, I get 6. 2 square root of 4 minus 2 times negative 1 is negative 2. Square root of 2 is 12. Square root of 24. Now you have to simplify it. So I have 6 square root of 4. Well, that's easy. That's 2. So I have 6 times 2, which is 12. But I have to break down the 24. Well, let's see. I have 1 and 24, 12 times 2, 3 times 8, 4 times 6. So I'm going to break this into 2, 4 times 6. I can break this down like so. So I have 2 times square root of 4 times square root of 6. This is 2, so 2 times 2 is 4. Square root of 6, it is a negative. So I have 12. I bring the 12 down. 12 minus 4 square root of 6. All right, so make sure you write this one down, and we're going to go over a couple others. Now, do you remember FOIL from Algebra 1? First, outer, inner, last. Okay, this is when we have two binomials that we're multiplying together. What we do is it's kind of a distributive property problem. You're going to take the 4 times the square root of 2, and you're going to multiply it times the square root of 3. So that's 4 times 1 is 4. Square root of 2 times the square root of 3 is the square root of 6. Then you're going to do 4 square root of 2, and you're going to multiply it times square root of 2. So 4 times negative 1 is a negative 4. Square root of 2 times square root of 4, or square root of 2 is square root of 4. Sorry, I was doing the answer in my head. Okay, so I did that one. Now, so that was the first terms in each binomial. Then I'm going to do the outer terms, so the outside ones. This one on this side, this one on this side. Let me change colors because now we're going to do the inner. We're going to do the square root of 3 times square root of 3. And it's a negative square root of 3 and square root of 3. Now remember our rules. Square root of 3 times the square root of 3 is going to give me 3. Now this one's negative, so I have to have a negative 3. So this is going to be negative 3. Okay? You could also look at it as you had the negative square root of 9, which is still negative 3. Then, so I did first outer, inner. Now I'm going to do the last terms. Okay? Last terms are going to be the negative 3 times the negative 2. I can multiply what's inside. So I have negative 3, negative 2, so that gives me a positive. So positive square root of 6. So now that I've done all of this, I have to combine, simplify if you can. I'm going to make a comment here so you can write it in your notes. Simplify if you can. I can't simplify this, so I can't. So I'm unable to simplify. Well, the 4 I can, right? So the 4 is going to become a 2. So I'm going to have, let's rewrite it all in one. So I have 4 square root of 6 minus 4 times 2 is negative 8 minus 3 square root of 6 plus square root of 6. So I'm going to do these two I can combine, and I'm going to have 5 square root of 6, right? 4 plus 1 because there's a 1 there. Now I have negative 8, negative 3, so I get negative 11 plus 5 square root of 6. Special case, difference of squares. This is going to be very important for our next lesson. So, yeah, I don't know if you remember this from Algebra 1, but we have a difference of squares, meaning I have a negative and a positive, okay? The difference of squares actually refers to the answer, but this is going to be the setup. So we have square root of 3 minus 1, square root of 3 plus 1. Go through the same steps of FOIL. So we're still going to use FOIL. So I'm going to come up with some colors here. So I have the square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is 3. Okay, so square root of 3 times the square root of 3 is 3. Then I'm going to do the square root of 3 times 1. Well, that's pretty easy, right? Square root of 3 times the positive 1 is positive square root of 3. Do the next one. Negative 1 times the square root of 3, well, that gives me negative square root of 3. And this is where the difference of squares part is going to come in. Then I do the last one. Negative 1 times a positive 1 gives me a negative 1. Now, when I go to combine like terms, this is how this works. Okay? When I go to combine like terms, 3 minus 1 is 2. Square root of 3 minus the square root of 3, that's a 0. So there's my final answer. The key here is you have the same terms, square root of 3 and 1. 1 is a negative, square root of 3 minus 1. 1 is a positive, square root of 3 plus 1. When you have this setup, the middle two terms cancel out, leaving you with usually with just one term, sometimes two, but most of the time just the one. Okay? Again, that's going to play a big part in the next section. So what I want you to do is I want you to pause the video and I want you to try these on your own. I'm not going to go through a lengthy explanation on these. Actually, I will on the square root of 2 to the third power. I'm sorry, I forgot these go to 3. Okay? Go ahead and try this first one using FOIL, 3 plus 2 square root of 5. I'll set it up for you here so that you understand what you have to do. Remember this, because it's squared, you're going to have 3 plus 2 square root of 5 times 3 plus 2 square root of 5. Now the square root of 2, if you notice, it's to the third power. So that means I have the square root of 2 times the square root of 2 times the square root of 2. That'll go the same for the 2 square root of 5. We'll set it up. Okay, give it a shot. See if you can figure out the final answer. All right, so here are the answers. Go ahead and take a look, see if you did them properly. If you have any questions on how I did them, you can always bring it up in class. Okay, so again here I did FOIL, combined my like terms. The square root of 25 became a 5. So I have 4 times 5, which is 20. Combine the 9 and the 20, I get 29 plus 12 square root of 5. For this next one, square root of 2 times the square root of 2 just gave me 2. And then I bring down the square root of 2. I can't do anything more, so my final answer, 2 square root of 2. 2 square root of 5 required a little bit more work. I get 2 times 2 is 4, 5 times 5 is 25. Well, the square root of 25 is 5. 4 times 5, 20. Bring down the third 2 square root of 5. Go ahead and multiply 2 times 20. I get 40, square root of 5, final answer. All right, so let's go over our fun fact. Why is the Ring of Fire called the Ring of Fire? The area encircling the Pacific Ocean is called the Ring of Fire because its edges mark a circle of high volcanic and seismic activities, or earthquakes. Most of the active volcanoes on Earth are located on this circumference. So if you take a look, we got Japan, these are all the islands on for Alaska and Russia. On down, if you look, San Andreas Fault in California is on it. A lot of stuff happens down in here in Central America. Chile, where there are a lot of earthquakes happen, is right down in here. So just a fun fact. All right, so what should you know after doing this lesson? First thing you should know how to simplify surds using multiplication rule and perfect squares. You should be able to add and subtract by simplifying them and combining like terms. You should be able to divide them. Remember, simplify and divide out what you can. You should be able to use the distributive property in FOIL to multiply expressions with more than one term. Recognize difference of squares, special case. We're going to go more in depth than 3-5 with this one. Okay? And understand the process to multiply 3 terms together. So with that, that concludes lesson 3-4.